I want to flex my muscle. First, the signal travels through the motor neuron to the neuromuscular junction. When the action potential reaches the neuromuscular junction, acetylcholine is released into synapse. Nicotinic receptors and acetylcholine bind on the motor end plate. Nicotinic receptor channels open when they bind, which lets in sodium ions. When enough sodium ions enter the muscle fiber, its resting potential goes up to negative 50 MV. This causes a muscular action potential that spreads throughout the fiber. The potential goes across the sarcolemma and through the T-tubule to get to the microfibrils. When the proteins join the calcium channel in the sarcoplasmic reticulum, muscular action potential forces calcium to go out the sarcoplasmic reticulum. The calcium ions then bind to the troponin, which displaces tropomyosin. This exposes the myosin binding sites on actin. When myosin heads connect, it is called a cross bridge. This is when ATP is hydrolyzed into ADP in inorganic phosphate. The ADP in inorganic phosphate then causes the myosin head to shorten the sarcomere. This action is called a power stroke. ADP in inorganic phosphate is released during the power stroke. This model shows a zoomed-in view of a sarcomere being shortened. A sarcomere is a singular muscle fiber, and this shows what happens when it is flexed. When somebody dies, their body goes through rigor mortis. This typically sets in 3 to 4 hours after death. This is caused by the pump dying and calcium floods the cells, causing them to flex and stiffen. ATP is not created after death due to the lack of oxygen. This means there is no ATP to attach to myosin and let it go. Rigor mortis normally ends within 48 hours. It ends because of a process called autolysis. Autolysis is the self-digestion of the body's cells. Autolysis takes over, breaks the muscle down, and becomes soft to further decomposition.